Have you ever came across a situation whereby you buy things online and then you don't receive those goods? Have you ever encountered a situation whereby you try to log into a certain network, right? It's a wireless network, using a password you're given by the administrator or by somebody who is part of that network, and you are not successfully logging in? Have you ever encountered a situation whereby you reply to an email or you send an email to somebody but you're not getting a reply? So this is due to errors that can happen while listed data is being transmitted. Welcome to my channel Koda Entertainment TV, where we focus on computer science, ICT, mathematics. These are the subjects that I offer. Today we want to look at errors that are found when transmitting data. We want to look at types of, alright, we have got errors, right? But we want to look at error detecting method, the methods that we can use to detect errors, right, in data transmission. In the previous video, remember, we looked at the USB, we looked at types of data transmission and so forth, right? So today we want to look at error detecting methods, right, detecting errors in data transmission. So this is what we want to look at in this video, detecting errors in data transmission. So right, let's say you sent your email address to somebody, right, and somewhere when that person received the email, maybe it was corrupted along the way, right, and the recipient receives the wrong email, and then he or she sends the information to you, but you don't get anything back, right? So when data is transmitted, it can gain or lose its value due to certain factors. It can be interference, it can be we said it can be interference, it can be attenuation, because as a signal travels over a long distance, it can lose some data, it can lose its what can I say, it can lose its strength, right? The signal can lose its strength, and again there can be interference. Remember, we said transmitting data using parallel, there are high chances of interference, right? Interference happening. Why? Because we'll be using multiple cables to transmit data. So when there is interference, data can gain or it can lose some values or components. So this will lead to a person who is receiving the message, receiving a broken message, receiving something that is not making sense at all. So it will be the burden of the receiving person to try and find the meaning out of the words he has received. So today we want to look at detecting errors in data transmission. How do we detect these errors? The methods that we can use to detect and correct errors. So this is what we are going to look at. So we have got about 5 methods, right, that we can use to detect and correct errors. So the first one being called Parity Check. That's the first one, the Parity Check. We have got Parity Check, we have got checksum, we have got automated repeat request, we have got check digit, right? So these are the methods that we have. Check. It is a way of detecting errors in data transmission, and it uses two approaches. It uses odd or even parity, right? There is odd or even parity. So when you're saying an odd parity, in an odd parity, the number of ones in your byte should be adding up to an odd number. That is an odd parity. If it's an even parity, the number of ones in your byte should be adding up to an odd number. Mind you, these parity bits, right? These parity bits, they can be added either to the right or to the left. So originally, the data would be contained in a 7-bit, right? In a 7-bit. Then the 8th bit would be the parity bit. So the 8th bit can be either to the left or to the right. So the 8th bit, remember, we said it is the parity bit. So let's say, for example, in our bit or in our byte, right, maybe let's say there are 2 ones, right? It means in that scenario an even parity would be in use, and if we have 3 ones, it means an odd parity would be in use. So this parity, system is determined by the number of ones, or maybe let's say, for example, in our 7 bits of data, maybe there are 4 zeros and 3 ones, and we want to send this data using an odd parity, right? We want to send this data using an odd parity. If that is the case, we already have 3 ones and 4 zeros, but we want to send this data using an odd parity. It means our parity bit in this case would be a 0. Why? Because if we add a 1, we'll now be using an even parity, hence it will produce an error. So our parity bit should be a 0 in this case. But if we want to send this data using an odd parity, and we have got 4 zeros and 3 ones, our parity bit should be a 1. Why? Because you're saying in an even parity, the number of ones should be adding up to an even number, and in an odd parity, the number of ones should be adding up to an even number, right? So that's the difference. So I want to show you how it works. It's just a simple demo. All right, so we have got our 7-bit, right? 7-bit binary number. So this is a piece of data that you want to send. So if we are sending this piece of data using the odd parity, it means we have to add, right? Remember, we said in an odd parity, the number of ones should be adding up to 3, but in this case, we have got 1, 2. So it means if we are to send this as it is, would have used an even parity, but we said we want to use an odd parity. So for us to be able to use an odd parity, we count the number of ones we have. In this case, we've got 1, 2. So according to our rule, if we are using an odd parity, it means the number of ones should be adding up to an odd number. So we have to add a parity bit. So what type of a parity bit are we going to use? Since we have got 2 ones, it means we need a 1. We need to use 1 as a parity bit. So it is added either to the left or to the right, it doesn't matter. So let me just add this parity bit to the left. So this one becomes our parity bit. It becomes our parity bit. So now we have got how many number of 3s in our byte? Number of 3s, we have got 1, 2, 3. So it means we are using an odd parity. Odd parity because number of ones now adding up to an odd number, right? So this is odd parity. Our number of ones are now adding up to an odd number, which is 1, 2, and 3. So this is how odd parity works. So what happens is the data is transmitted, right? The data is transmitted, and then after the data has been received, then the receiving device or the receiver would check, right? The receiving device would check the number of ones, whether they are corresponding to the type of parity being used. So there is a communication that happens before transmission, right? Like the receiver is told that we are using an odd parity, meaning to say when the data is received, the data is being, it is checked whether the number of ones are adding up to an odd number. If they are adding up to an odd number, then it means there was no error, right? But all of a sudden, if the number of ones are now adding up to an even number after being received, it means there was an error. So this is how an error is detected using odd parity. So let us demonstrate even parity. So with an even parity, the approach is the same with an even parity. Alright, so let us use the same binary number. Our binary number has got 1, 2, 3, 4, 5 zeros and what? 2 ones. Remember we said in an odd parity, the number of ones must be adding up to an even number. So in this case, the number of ones are already adding up to an even number, which is 1 and 2. So what should be our parity bit? So our parity bit should be a 0. Our parity bit, it should be a 0. Parity bit, it should be a 0. Why? Because the number of ones is already adding up to an even number. So this is even parity. So the explanation is the same. Before the data is transmitted, there is a communication, right, between the sending and the receiving, device as to the type of parity being used. So the receiving device is advised that an even parity is being used, right? An even parity is being used, such that when the receiving device receives the data, it checks if the number of ones are adding up to an even number. If they are adding up to an even number, then it knows that no errors were introduced when the data was being transmitted. But if the number of ones are now adding up to an odd number, it means there was an error when the data, an error was introduced when the data was being transmitted. So this is the first method, error detecting method, that we have in data transmission, which is parity check. There is also a scenario whereby an error can happen but will not be able to, will not be detected by parity check. You might wonder or ask how or why. Let's say, for example, you are using an odd parity, right? And remember, in an odd parity, number of ones should be adding up to an even number. Let's say we have got 4 ones in our byte. Then we send the data. When the data is received, then the receiving device checks, it checks, and then it finds that there is, 4 ones, right? But an error would have occurred. How would the error occur? Because there can be the interchange of these bits, or these bits will have been transposed. For example, let's say let us use 2, right? Let us use 2. We have got 2 our ones. We have got 2 ones in our byte, right? And then after the data is received, right? After the data has been transmitted, and when it is received, then the receiving device finds that there are now 6 ones, right? There are now 6 ones. Remember, 6 is an even number. 2 is an even number. So in that scenario, it won't be able to detect that an error has occurred, because the number of ones are still adding up to an even number. So this is a scenario where an error could be introduced and will not be able to be detected. So this is what we had to discuss in the parity check. So in the next video, we are going to look at another method of error detecting, which is called checksum. So this is what we are going to look at in the next video. Thank you very much. Please subscribe to my channel. Follow me on my social media platforms. All the details are provided in the link in the video description below. Thank you very much.